This is an overview of Chapter 6. So Chapter 6 is talking about elasticity, the responsiveness of demand and supply. So we're going to talk about the price elasticity of demand and its measurements, the determinants of the price elasticity, the relationship between price elasticity of demand and total revenue, other demand elasticities, and also the price elasticity of supply and its measurement. So some argue that people do not vary the quantity of gasoline they buy as the price changes. Think about yourself. Do you change your driving habits if gas was to go over $4 a gallon again? Would that change where you drive or how much gas you buy? So from May 2010 to May 2011, the price of gasoline rose for about a third, from $2.79 to $3.76. Gasoline consumption fell about 5%. So people do respond to incentives by changing their behavior as price, income, and price of related goods change. So this is kind of what we're going to talk about in Chapter 6. This chapter explores behavioral changes. So we're going to define the price elasticity of demand and understand how it is measured. Although we saw that consumers did change the amount of gasoline they bought, they did not appear to change it by very much. I think about myself, and if I have to drive to work, let's say potentially I have an hour commute. Well, if gas goes from $2 to $4, my hour commute doesn't immediately change. I may not be driving around on the weekends to take trips, but I can't change that commute in the short run. In the long run, I could potentially move closer or do things like that. So how can we come up with a sensible way to measure how much quantity changes when price changes? One idea is to look at the slope of the demand curve. But this won't work since the value of the slope depends on the units used to measure the axis. A better way to measure the responsiveness of quantity demanded is to think of this in terms of percentage changes. This avoids problems with unit measurement. So here's a formula. If you're watching this video, write this down. You can replay the video, but price elasticity, it's also in your book, equals percentage change in quantity demanded divided by the percentage change in price. Although the slope and price elasticity of demand are related, they are not the same thing. Since price and quantity change in opposite directions on the demand curve, the price elasticity of demand is a negative number, but we don't usually talk about it as a negative number. So we often refer to it as more negative elasticities as being larger or higher. A large value for the price elasticity of demand means that quantity demanded changes a lot in response to a price change. This really wouldn't be gasoline. It would be more things like luxury goods or things that you're much more sensitive to about price. Formally, we say that demand is price elastic if the price elasticity of demand is larger absolute value. So we're not taking into account that when you calculate this, it'll come out with a negative number. Larger than 1. So a 10% increase in price would result in a greater than 10% decrease in quantity demanded. This is how sensitive are we to pricing. And demand is price inelastic if it is price elastic of demand is smaller than 1, which means a decimal point in absolute value. Absolute value, again, means we're not taking into account the negative number. That is, it is closer to 0, indicating that the quantity demanded changes little in response to a price change. Demand is unit price elastic if the price elasticity of demand is exactly equal to -1. So let's look at this in terms of graphs. So on here we have the dollars per gallon and the quantity of gallons demanded per day. So at $4 a gallon, there's 1,000 gallons per day demanded, point A. Now, when we change the price to $3.70, there's 1,200 gallons per day increase. So, demand. If we cut the price from A to C, so $3.70, if demand only changed from 1,000 to 1,050, that would be inelastic. Point B would be an elastic demand. So let's talk about this in terms of formula. Percentage changes have unfortunate characteristics. So percentage change from A to B is not negative of the percentage change of B to A. So here's an example. On the previous slide, from moving from point A to point B, quantity increased from 1,000 to 1,200, an increase of 20%. However, from B to A, the quantity decreased 16.7%, so it's not exactly 20% each way. This would mean that elasticity from A to B was different from elasticity from B to A, an undesirable characteristic. To avoid this, we calculate percentage change by using a midpoint formula. So the percentage change is A minus B divided by A plus B divided by 2. The midpoint formula avoids confusion from A to B and B to A. So here is the price elasticity of demand. Quantity demanded 2 minus quantity demanded 1 over quantity 1 plus quantity 2. This is like A, B, divided by price change. So this is price change from 2 to 1, 1 to 2, divided by 2. So this is the formula for price elasticity. The first term in the percentage is quantity, using the midpoint formula. The second is price. So this is change in quantity divided by the change in price. But this is just averaging this, so we use a midpoint formula between A and B and B and A. How does this really work? So, an example. At your gas station, they cut the price from $3.50 to $3.30, and gasoline sales went up from 2,000 gallons to 2,500 gallons per day. First, we must calculate the price elasticity. We need to average quantity and price. So here's how we average it. So this is averaging quantity. 2,000, which is here, point A, previous. 2,000, point A, plus 2,500 divided by 2. So 22.50, average price. 3.50 plus $3, these are the two prices, divided by 2, 3.40. So now we're going to move on to calculate this. So 2,500 minus 2,000, which are these two numbers, divided by the average, times 100. So the percentage change in quantity demanded was 22%. Now the price change. It's $3.30 minus $3.50 divided by $3.40, which was the average, times 100, is a minus 5.9%. Now, 22.2% divided by minus 5.9% is negative 3.8%. Here's the thing. Absolute value would make this a 3.8% change. Is 3.8% greater than 1? So it is, and therefore we would say that the price demand is elastic. Now, as you can see, the closer you get to a vertical line, so this one is more horizontal, this has a closer to a vertical line, the closer you get, the more inelastic it becomes. So let's talk about this. The price change is the same, $3.50 to $3.30. So therefore, the minus 5.9% average that we calculated, the change in price remains the same. But now we're talking about the change in quantity only went from 2,000 gallons to 2,100 gallons. So 2,100 gallons minus 2,000 divided by 20,050 times 100 equals a 4.9% change. So 4.9 divided by minus 5.9 is a negative 0.8. This is less than 1 absolute value. Therefore, on this line, this slope demand curve would be inelastic. The smaller than 1 is inelastic. While slope and inelasticity are not the same, they are related. If two demand curves go through the same point, the one with the higher slope has a higher or more negative or more elasticity. A vertical demand curve means that the quantity demanded does not change at all with price. So elasticity would be 0 on a vertical demand curve, also known as perfectly inelastic. A horizontal curve means that the quantity demanded is indefinitely responsive to price changes, which means elasticity is infinite. A horizontal demand curve is perfectly elastic. So this is going to give you kind of an idea of what the curve would look like, what the change would look like, and whether it's elastic, the demand is elastic or not. So if demand is elastic, then absolute value of price elasticity would be greater than 1. Example to the right. If the curve is inelastic, then it would be less than 1, the 0.8%. If the unit elasticity is equal to 1, and if it's perfectly elastic, the demand curve is horizontal. It means that it does change every time related to price, right? And if it's perfectly inelastic, price does not matter. There's always a demand of 1,000 gallons. So now back to the question, do people respond to changes in the price of gasoline? We can now use our knowledge to answer this question in economic terms. Gasoline demand is inelastic. The quantity demanded does not change much as the price of gasoline changes. It is not perfectly inelastic. It is somewhat responsive to price. So we do change our habits a little bit, but not always everything. Which panel shows this? Which one would be inelastic? This is perfectly inelastic, so that wouldn't be our answer. This is inelastic, but it still changes somewhat related to price. So, determinants of price elasticity of demand. Why do some goods have higher price of demand elasticity of demand while others have a low price elasticity of demand? There are several characteristics of a good, of a market, etc., that must determine this. The availability of close substitutes. So if I were you, I'd be taking notes and writing this down. Number 1, determinants of price elasticity, also listed in your book. The availability of close substitutes. If a product has more substitutes available, it will have a more elastic demand. Think about it. If I can go get a substitute, something that I feel is closely related to this and I could use instead, therefore, I would be more sensitive to price. There are few substitutes for gasoline, so the price elasticity of demand is low. There are many substitutes for, let's say, Nikes. There's a million different types of running shoes. So if you're buying running shoes and the price of Nike has gone up, you could just buy a competitor. So it's elastic. Over time, people can adjust their buying behaviors more easily. Elasticity is higher in the long run than it is the short run. So passage of time. Like I said, if I commute and gas has gone up significantly, I can't immediately move, usually. That takes time. Examples. What will people do to adjust their gasoline consumption? I could buy a more fuel-efficient car. I could move closer to work. The other thing, so our second is passage of time. Our third is when a luxury, whether it's a good that is a luxury or a necessity. People are more flexible with luxury goods than necessities, so price elasticity of demand is higher for luxury goods. People consider milk and bread necessities. They will buy them almost every week, regardless of price. And if the price goes down, they won't drastically increase consumption. Just because the price of milk went down, it doesn't mean I'm going to drink more milk than I normally drink. The definition of the market. The more narrowly defined the market is, the more substitutes are available, and hence the more elastic the demand is. Example, you might believe there is no good substitute for jeans, so your demand for jeans is very inelastic. You're going to buy jeans either way. But if you consider different brands of jeans, you might be more sensitive to the price of a particular brand. Number 5. So definition of the market. Number 5 was 4. Number 5 is the share of the good in the consumer's budget. So the larger it is of my budget, the more sensitive I am to price changes. So if it is a small portion of my budget, I will likely not be very sensitive to a price change. I buy table salt once a year or less. So if the price changes, it doesn't mean I'm going to stop buying table salt. Changes in price of housing do affect where people choose to live. Remember, goods that are inelastic with inelastic demand have a price elasticity between 0 and -1. Goods that are elastic have an elasticity greater than the absolute value of -1. Try to guess the price elasticity of the demand of the following goods: milk, grapes, Coca-Cola, cigarettes, and residential gas. Are we sensitive to changes in milk prices? Probably not, so it's less than 1. Grapes. I think there's a bunch of fruit that I could substitute for grapes. Okay, it's greater than 1. Coca-Cola. Greater than 1. We could substitute lots of different competitors for Coca-Cola. Some people who really love Coca-Cola would disagree. Are there a lot of substitutes for cigarettes? No. And what about natural gas? Think residential natural gas. So if I have to heat my stove with natural gas, can I go out and get a substitute for that? Probably not. So it's inelastic. Let's talk about the relationship between price elasticity of demand and total revenue. If you are a business owner, you need to decide how to price your product. Later in this course, we will talk about pricing discrimination and pricing terms and things like that. But this is all part of it. How elastic is the demand for your product? How many customers will I gain if I cut my price? What will happen to my total revenue if I cut my price? Knowing the price elasticity of demand for your product can help you answer these questions. Total revenue, just for definition purposes, total revenue is the amount of funds received by a seller of a good or service calculated by multiplying the price per unit by the number of units sold. So let's see an example. Suppose the demand for your product is relatively price inelastic, which means price really isn't going to affect the demand too much. Customers are not sensitive to the price. As you decrease the price, you expect to gain few additional customers. The few additional customers do not compensate for the loss in revenue, so overall revenue goes down. Suppose demand for your product is relatively price elastic. This means the customers are very sensitive to the price of your product. As you decrease the price of your product, you expect to gain many additional customers. The many additional customers more than compensate for the loss of revenue, so overall revenue goes up. You know, a good local example I can think about this is FL Roberts. I don't know if any of you have the monthly car wash pass, but they started out with the monthly car wash pass. So you just pay a monthly fee and you can get your car washed as many times as you'd like at $30. And I'm not sure they had a great response to that because car wash is kind of a luxury item. Sometimes you really need it, but it's not a necessity like bread or milk. So this means that the price is very elastic. You're going to respond to it. Now the price is $14.99 a month for unlimited car washes. And I will tell you, there is a line at FL Roberts all the time, which means that in this case, I believe that the many additional customers compensated and overall revenue by selling this pass went up. Here's an example. Revenue before a price cut. Demand is inelastic, which means it's less responsive to price change. So, revenue at point A, it was 1,000 units, right here, at $4 a unit. So total revenue is $4,000. They cut the price to $3.70, but only sold an additional 50 units. So therefore, the total revenue is $3,885. This is inelastic, and overall revenue went down. Now, what if the demand was elastic? Look at the slope of the curve. It's not exact, but it's related. So now, $4 and we sell 300 units, so revenue is $4,000. But now at $3.70, people responded significantly, and we sold 1,200 at $3.70, so actual revenue, total revenue went up. This is because it was elastic. So, write this down. The formula for price elasticity of demand is percentage change in quantity demanded divided by percentage change in price. So if it is greater than 1 in absolute terms, then quantity demanded goes up as the higher percentage than price and raising the revenue. The special case occurs when the price elasticity of demand is -1. The percentage change of quantity equals the percentage change in price, so therefore revenue does not change. That's a special circumstance. So suppose we have a linear curve. Initially, total revenues rise, suggesting it is inelastic. So this isn't a straight line. It's a linear curve. We'll show you on the next page. So from 32 all the way down to price of 0, the quantity demanded. But then total revenue starts to fall, suggesting demand is elastic. So let's look at this. So at this point, it's an upside down U-shaped curve. So at this point, it's good when the demand curve is elastic, but then it starts going back down. So the price continues to fall and revenue actually flattens out and demand per unit is elastic. Then the price falls even further and demand becomes inelastic. Estimating price elasticity of demand. We can see that knowing the price elasticity of demand would be very useful for a firm. But how can they know this information? for a well-established product. So the product has been out in the marketplace, let's say Coca-Cola. Economists can use historical data to estimate the demand curve. To calculate the price elasticity for a new product, firms must rely on market experiments. With market experiments, firms try different prices and observe the change in quantity demanded as a result. When Sony and other television manufacturers produced 3D TVs in early 2010, they had estimated demand. Would the consumers be price sensitive to price? That is, would the demand be elastic? If so, they could not sell 3D TVs for much more than existing TVs. So, unfortunately for Sony, customers were very sensitive to the price, more sensitive than they expected, and sales for 3D TVs were flat. By the end of 2010, firms were cutting prices by 40% in order to increase revenue, because basically they're sitting on all these technology products, TVs, if you will, that nobody wants because they said, I'm not really willing to pay that much more for 3D. I'm very sensitive to the price of TVs. Defining cross-price elasticity of demand and income elasticity of demand, and understanding their determinants and how they are measured. So we examined in Chapter 3, which we reviewed, we discussed the concepts of complements and substitutes. Substitutes are goods and services that can be used for the same purpose. Red Bull and coffee was an example used in Chapter 3. Goods and complements, chips and salsa, goods and services that are used together. So cross-price elasticity is the percentage change of quantity demanded of one good divided by the percentage change of another good. So this figures out whether it is responsive. So if the products are substitutes, then the cross-price elasticity will be positive. Two brands of tablet computers. So therefore the change in one price will change the quantity demanded in another price. Complements, it will be negative. Tablet computers and applications downloaded from online stores. If I'm not buying any tablets, then I'm probably not downloading any applications. If they are unrelated, there will not be any price elasticity, cross-price elasticity. Tablets and peanut butter, they're just not related. We also examine what we discussed in Chapter 3 as normal and inferior goods. A normal good and service for which quantity demanded increases as income increases. So this is anything that we think about, like, so for example, food. I might eat different types of food as my income increases. An inferior good, we think about the Big Mac or the dollar menu at McDonald's or potentially Subway. We eat there because it is inexpensive, so we demand more of it when we have less income. Inferior good. And income elasticity of demand measures the strength of the effect of income on the quantity demanded. So percentage change in quantity demanded divided by the percentage change of income. If the income elasticity demand is positive but less than 1, then the good is a normal necessity. Example, bread. If it is positive and greater than 1, it is a normal luxury. A luxury good is a quantity demanded that responds more proportionally to price changes. Like the sale of boats. If income keeps going down and we're in a bad economy, boat sales suffer, right? If it is negative, it's actually an inferior good. Think about ramen noodles. So this is talking about the market for the income elasticity and the cross-price elasticity for alcoholic beverages. So in general, price elasticity for beer is inelastic. That means people are going to drink beer whether there's price changes or not. But beer and wine are substitutes. So the cross-price elasticity between beer and wine, it means they are substitutes. So someone might drink wine or might drink beer depending on price. The cross-price elasticity between spirits, which is liquor, and beer is still substitutes, but not as strong as beer and wine because it's less than the beer and wine number. Income elasticity. Beer is an inferior good. As income rises, consumption of beer falls. Look at how much this is over 1. So income, however, wine and spirits are luxury items, and as income rises 10%, demand for wine rises 50%. Think about that. And demand for spirit rises less. So people are going to drink wine if they make more money. Interesting, right? Do you think these are accurate for the American college student? Maybe, maybe not. Use price elasticity and income to analyze economic issues. Over the past century, farms have become more efficient in producing food. This might appear to make farms more profitable, hence encouraging people into farming. But the number of people in farming has fallen substantially from 23 million in 1950 to 3 million in 2011. Why have productivity gains in farming led to fewer people choosing farming? Well, let's talk about what's happened to the price and supply and demand. In the 1950s, farmers produced 1.0 billion bushels of wheat at $18.56 per bushel. Over the next 60 years, rapid increases in farming productivity caused a large shift in the supply curve to the right, so supply went 1950 to here, driving down the price. Because demand didn't change that significantly. Income elasticity of demand for wheat was low, so demand for wheat increased little over this period, because we're going to demand wheat at the same, it's not a luxury good, right? So demand for wheat is also inelastic, so the supply shift with a small demand shift drove the price from $18.50 in 1956 to $5.70 a bushel. So define price elasticity of supply and understand its main determinants. So supply is very similar to the demands, but we're going to talk about it. So price elasticity of supply, the formula is percentage change in quantity supplied divided by percentage change in price. And price elasticity of demand is quantity demanded and change in price. So this is quantity supplied for supply and quantity demanded for demand. It's the same sort of calculation methods. We apply the midpoint formula. Price elasticity of supply depends on the ability and willingness of firms. Remember, think of from a business standpoint when you think supply, to alter their price as they produce. Time period in question is critically important for determining price elasticity of supply. Suppose you're a wholesaler of grapes, and the wholesaler price of grapes doubled overnight. Farmers could do little to increase their quantity immediately, so the initial price elasticity would be close to zero. Over time, farmers could plant more fields and grapes, so over several years, the price elasticity of supply would rise. Oil producers cannot change output very quickly. When demand increases suddenly, prices rise, acting as a rationing mechanism for the increase in demand. Here to here. See the price change. On the other hand, during a recession, demand for oil falls. They can't adjust, so the price falls from here to here. That's because some things that you're supplying can't be immediately changed, just like I can't immediately move if gas prices go up. Much the same terminology applies. So it's elastic, inelastic, unit elastic, perfectly inelastic. If supply is elastic, the value of price elasticity is greater than 1. If it is inelastic, it is less than 1. If unit elastic is equal to 1, it is perfectly elastic if it is a horizontal line for supply. That means they can't supply anymore related to price. It is perfectly elastic. Perfectly inelastic. Sorry, this is perfectly inelastic. That means no matter what the price is, this is all that we can supply. Knowing the price elasticity of supply can help us predict the effect of change in demand will have. When demand increases, we know market equilibrium price and quantity will increase. But if supply is inelastic, quantity supplied cannot change much in response to the demand change, so the price will rise a lot. If supply is elastic, price will rise much less. The next 2 slides illustrate these statements. So, parking on the 4th of July is an inelastic supply. The demand, so typical demand for parking, and then there's a huge increase for demand for parking on July 4th. But it just changes the price because we really can't, at the beach, squeeze out too many more parking spots. But if it was elastic, notice the shape of the line, the price would change much less. So here is percentage of change in quantity demanded divided by percentage change in price. So absolute value of the percentage price elasticity. If it is elastic, it is greater than 1 and total revenues fall. If it is inelastic, it is less than 1 and total revenues rise. This is the supply. If it is unit elastic, it is equal to 1 and total revenues remain unchanged. So this is a summary. Elasticity of demand. Percentage change in quantity demanded of one good divided by the percentage change in quantity of another good. If the two types are substitutes, the cross-price elasticity will be positive. Complements will be negative, and unrelated will be 0. If we are talking about the income elasticity of demand, the change in demand over the change in income, if it is a normal and a necessity, it'll be positive but less than 1. If it's normal and luxury, it'll be positive and greater than 1. And if it's inferior, it'll be a negative. On the price elasticity of supply, the percentage change in quantity supplied divided by percentage change in price. If it's elastic, it's greater than 1, inelastic less than 1, and unit elastic equal to 1. While price elasticity of demand is strictly negative, we often refer to it as a positive number. So misconceptions to avoid. Don't think because of this the quantity demanded and price move in the same direction. The cross-price elasticity of supply, negative means complements, positive means substitutes. Inelastic refers to the quantity demanded or supplied not changing much in response. Don't confuse this with inferior. And that is the overview for Chapter 6, Price Elasticity. There is also a video for Khan Academy on this as well to help better explain or to give you more reinforcement with different examples.